Hey guys, welcome back to a brand new video in our series. We're on our second topic, polar coordinates. Hopefully by the end of this video, you will have a basic understanding of how to read and to perform plotting on a polar graph. We will also be looking into rectangular coordinates and polar coordinates and how we can convert them from one to the other. Let's talk about rectangular and polar coordinates. We know rectangular coordinates as a Cartesian plane of x and y. Its ordered pairs are x and y. But if we look at polar coordinates right here, we have a whole different reference system. From the center here, it references these radiuses that span at an angle that comes from the positive y-axis. So it starts from here and it goes 10 degrees, 20, 30, 90, 180, 270, and 360. And all of these points can be within this entire 360 realm, but at different radiuses. This is radius of 2, and this is a radius of 3, and this is a radius of 1. Their ordered pairs are considered r and theta. Okay, let me just give you an example right here about how we can plot polar coordinates. So, let's say I wanted you to plot 4 and let's say 45 degrees. Do it on a polar graph. Well, the radius is 4 and the theta angle is 45 coming from the positive x-axis. So let's write that down. Draw our graph. Let's just consider each circle a unit of 1. 1, 2, 3, 4. So the radius is 1, 2, 3, 4. It's located anywhere around this circle right here. But we have an angle of 45. So the theta angle is approximately, we're just guesstimating here, this type of angle. Okay, so it meets at 4. Therefore, this is the polar coordinate for 4 and 45 degrees. Allow me to give you one more example. I want you to graph on the polar graph 3 and 300 degrees. Let's try it out. I'll draw a bunch of circles. Draw 4 circles. Okay, so the radius is 3. So from our pole here, 1, 2, 3, could be anywhere in this third circle. Now we have 300 degrees. So from the positive y-axis, we know 300 degrees is somewhere around the 4th quadrant. I will assume it's around here-ish. In this line, we know that the radius is 3, so from this point, it meets with the pole. And that is how we draft the polar coordinate. Okay, now let's spice things up. What if I asked you to graph negative 300 degrees? Well, we have 300 degrees as a reference. The negative, or like the opposite of that, would practically be this length right here. An alternative for negative 3 and 300 would be 120. Reason being is that from the x-axis, the reference angle here is 60 degrees because 360 subtract 300 is 60. The reference angle is the same here basically. So 60, we'd minus 180 subtract 60 to find this angle right here, which is 120. The radius here stays the same, therefore you have an alternative polar coordinate of 3 and 120 degrees. Let's start converting polar coordinates to rectangular coordinates. Right here we have a polar coordinate 4 and 60 degrees. How can we relate this to the Cartesian plane on a rectangular axis? Well, on this xy axis, we can see that we can build formulas such as x equals r radius cos theta, y equals r sin theta, and r equals the Pythagorean theorem, which is root x plus y, both of them squared. We know that this is r and this is theta. With this, we could totally just plug these in and substitute for x and y. X equals 4 cos 60 and y equals 4 sin 60. We don't need this r formula because in the end, our goal is to reach the result of a rectangular coordinate, which is only needed with x and y. I see something very familiar here. Cos 60 and sin 60 are from the unit circle, and they are exact values from the unit circle. They are a half and square root 3 over 2. We are multiplying this by 4, so we put the 4 here, 4 here, and we should get our answer. 4 times 1 divided by 2 equals 2. That's our x point. And our y point, 4 and 2, they can be simplified to 2 with root 3. And that is how we convert a polar coordinate to a rectangular coordinate. Boom. Alright, so now let's switch it around. Right here, we have an x and y value. This is a rectangular coordinate. Our end goal is to give it a polar coordinate. So we're putting it into r and theta. So we have a formula right here. R equals the square root of x squared plus y squared. We could totally do that to find r. But how do we find theta? Well, we can easily calculate theta by using the inverse of tan over y in r. Let's try it out. I'm going to calculate theta first, right here. Theta equals inverse tan of 3 and negative 4. Something I want you guys to note is that negative 4 and 3, they are in quadrant 2. But for the sake of this, I want to just find the reference angle. Therefore, we don't need to add the negative 4. We just calculate that and we get angle 36.87 degrees. Since it's in quadrant 2, we'll take 180 degrees and subtract it by its reference angle because it's coming off the x-axis. So our actual theta would equal 180, subtract 36.87. That should equal us 143 degrees. Let's underline that to keep it later for our final result. Let's find the radius. 4 squared, negative 4 squared, plus 3 squared. You could already look ahead. This would be 16 plus 9, which is root 25. Root 25, r equals 5. So, underline that. We have r and we have theta. That's all we need for a polar coordinate. So therefore, our polar coordinate would be 5 and 143 degrees. We have just converted rectangular to polar. This goes the same for equations with theta. There's no r dependency, so there's no way for a radius to tell it where to stop. So negative 350 degrees is approximately very close to 360. There's no radius telling it where to stop, so it keeps on going. We don't know whether or not it's negative or positive, so it actually keeps going on the other side also. This goes the same for 30 degrees. 30 degrees is approximately right here. Same principles apply, just like the 350 degrees, and 30 degrees right here. And those are just a few equations for just theta alone. The last equation before I end this video that I want to really briefly mention is this equation right here. It's not quite as easy as just having r and theta, but it can be done by making a chart. So right here is theta. This part of the chart is r equals 2 times 1 subtract cos theta. And this would be what cos theta would equal. So what we could do here is that we could just add a bunch of angles of theta as we want and substitute it for theta right here to find cos theta. So once we have those coordinates, we can apply it onto a graph and we can see what kind of shape it makes. And it's going to take a while for me to do it, but it looks something along the lines of this once you actually graph it. So to review what we learned today, we learned how to read and plot polar coordinates, we learned how to convert polar and rectangular coordinates to one another, and we also showed you a few equations in terms of polar coordinates. Tomorrow we'll be ending polar coordinates with complex numbers in polar coordinates, so hopefully you stick around for that. If you liked the video, please spank that like button and subscribe. Thank you for watching. Peace out.